In this tutorial, what we're going to be discussing is we're going to be discussing how to use the Aero modeling toolbox. Now, what the Aero modeling toolbox does is it returns a thin sliver of the Aero map across a particular set of data that we're looking at. So, to use the Aero toolbox, we basically need to do two things. Number one, we need some race car data, and we need a car file that pertains to that race car data. So, let's load up a car file that's the car file that's relevant for this data, and then we're going to go to the simulate aerodynamic modeling option to basically import the information into our Aero toolbox. Our next here, we're going to be basically using our monster import file. So we'll click on the add monster import file, double click on baseline1.txt, and that basically imports our data. Now, if the file had loads, I would have clicked here first and then added the monster import file. But this file didn't have loads, so I didn't need to do that. What we then need to do is we need to indicate the sampling rate that we're sampling this at. We then indicate the fact that this has been zeroed on the ground as opposed to the air. We need to indicate the downforce tolerance, the drag tolerance, and the aero balance tolerance. What this does is that as I mentioned before, the Aero modeling toolbox will basically return you a thin sliver of what your coefficient lift times area is, your coefficient of drag times area, and your aero balance. What this represents is basically a standard deviation filter. It will get these results, take the mean, and then basically what it will do is anything that falls outside of a standard deviation of the magnitude indicated here, it cuts out. Now, if we were using tyre loads, we would indicate that as 1, but clearly we're not using tyre loads here. So we set that as 0. And lastly, to indicate to the numerical model that we're going to be using tyre loads, we hit this as 1. So to commit that, we click on OK, and the next step of the process is to go to the Start Simulation button. So we hit the Start Simulation button, and it goes through, and as you can see, down here, it pops up with an Aero analysis toolbox window for us to look at the results. But you'll see here that we've got the mean we've got the mean downforce, the mean CLA, the mean CDA, the mean aero balance, and the standard deviations. That's the standard deviations for the aero, the standard deviation for the drag, and the standard deviation for the aero balance. So what we can do here is this little window basically will do a curve fit of what you're looking at. So the first thing is, if you click on View Right Height Envelope, this basically captures the right height envelope that we've captured. So you can see here that we've got front right height and we've got rear right height. The next is the downforce characteristic, and as you can see, it basically does a 4-quarter fit of the downforce of our downforce information. Now, if that's a little bit spurious, we can always go to a second order fit, and that basically does a second order fit. And it's exactly the same situation for drag and for aero balance. And what's more, we can also play around with these various curve fits. And if we're happy with that, we can basically export it to a file of our choice. So once we're happy with that, we click on OK, and we're done. Now, basically what this does is it generates this file. It basically generates this file called Aero Analysis Results.dat. If we open that up, you can see here basically we've got a column of 5 lines. We've got front right height, rear right height in millimeters, CLA, CDA, and aero balance. Now, what we can do is that once we've run through enough of these results, we can concatenate these files into a very, very big file, and you can use tools such as MATLAB and Excel to basically do a surface fit to basically plug the results into to plug the results into here. So that's basically how you do your Aero toolbox. I'm going to talk about how to do the how to generate surface order fits. But that's your first step in generating an aero map.